Testing a ring circuit is one of the most important skills for electrical apprentices, trainees, and anyone involved in domestic wiring. A ring circuit, commonly found in UK homes, allows electricity to flow through multiple socket outlets in a loop. Ensuring that a ring circuit is installed correctly and functions safely is essential for preventing faults, electrical shocks, and potential hazards. In this guide, we'll cover everything you need to know to test a ring circuit safely and effectively. Step 1. Understand the ring circuit. Before testing, it's important to understand the basic structure of a ring circuit. A ring circuit starts at the consumer unit, travels through each socket outlet, and returns to the consumer unit. This creates a continuous loop, allowing current to flow in two directions. The main conductors in a ring circuit are line, live, carries the current to appliances neutral, returns the current back to the source earth, provides safety in case of a fault. Ring circuits are commonly protected by a miniature circuit breaker, MCB, and, in most modern installations, by a residual current device, RCD. Knowing the layout and components of the ring circuit is crucial before performing any tests. Step 2. Prepare for safe testing. Safety is the first priority when working with electrical circuits. Never attempt to test a circuit without isolating it properly. Here's how to safely prepare for testing. Identify the specific circuit you want to test. Turn off the corresponding MCB or remove the fuse at the consumer unit. Lock off the breaker if possible to prevent accidental re-energization. Use a proving unit or a voltage tester to ensure the circuit is dead before touching any wires. Safe isolation ensures that you do not come into contact with live conductors, which could result in electric shock or serious injury. Step 3. Continuity testing. Once the circuit is safely isolated, the first electrical test is the continuity test. Continuity testing checks that the conductors form a complete loop from the consumer unit to the farthest socket and back. Here's how to perform continuity testing step by step. Set your multimeter or continuity tester to the correct mode. Connect one lead to the live terminal at the consumer unit. Connect the other lead to the live terminal at the farthest socket in the ring. Note the resistance reading. It should be very low, typically under 1 ohm. Repeat the same process for the neutral and earth conductors. A high resistance reading indicates a break, loose connection, or faulty conductor. Correcting any faults before energizing the circuit is essential for safety. Step 4. Insulation resistance testing. After confirming continuity, the next test is insulation resistance testing. To perform this test, set the insulation tester to the appropriate voltage, usually 500 volts for domestic circuits. Connect the leads between line and neutral, line and earth, and neutral and earth. Press the test button and observe the reading. A healthy installation should have a resistance reading of at least 1 megaohm. Lower readings could indicate damaged insulation, moisture ingress, or degraded cables. Insulation resistance testing helps prevent electric shock and protects appliances from faults. Step 5. Earth Fault Loop Impedance (ZS) testing. The Earth Fault Loop Impedance test, often called ZS testing, ensures that protective devices such as MCBs or fuses will operate quickly in the event of a fault. Here's how to perform ZS testing. Connect your ZS tester to a socket at the farthest point in the ring. Take the measurement and compare it to the maximum allowed ZS value for the protective device. Ensure that the measured impedance is below the required value, so the MCB or fuse will trip within the correct time. High ZS values may indicate poor earth connections, long cable runs, or undersized conductors, all of which need to be addressed to maintain safety. Step 6. RCD testing if present. Many ring circuits are protected by a residual current device, RCD. RCD testing is crucial to verify that the device will disconnect the circuit quickly in case of a fault. Steps for RCD testing. Perform a half-rated trip test first, followed by a full-rated trip. Optionally, perform a 5 times rated test for extra assurance. Confirm that the RCD disconnects within the manufacturer's specified time, usually under 300 milliseconds. If the RCD fails any of these tests, it must be repaired or replaced immediately to ensure continued protection against electric shock. Step 7. Document your results. Recording your test results is not just good practice. It's a legal requirement in many cases. Document all readings from continuity tests, insulation, resistance tests, ZS measurements, RCD tests. Maintain a logbook or digital sheet for future reference. Proper documentation ensures that all circuits have been tested correctly and that any faults have been addressed. It also serves as a valuable resource for apprentices, inspectors, and homeowners. Step 8. Common issues and troubleshooting. While testing ring circuits, you may encounter a few common issues. High resistance readings, often caused by loose connections or damaged conductors. Low insulation resistance could indicate moisture, damaged cables, or insulation breakdown. High Z's readings suggest poor earthing or long cable runs exceeding recommended standards. RCD not tripping, usually a faulty RCD or incorrect wiring upstream. Being familiar with these problems helps you troubleshoot efficiently and maintain safe, compliant installations. Step 9. Safety tips and best practices. Always wear appropriate PPE, including gloves and safety glasses. Never bypass safety devices to complete a test. Double check that the circuit is isolated before touching any wires. Use calibrated, approved test equipment. Repeat tests if readings seem inconsistent. Following these best practices protects you and ensures accurate testing results. Step 10. Summary testing. A ring circuit involves a series of logical steps designed to ensure safety, compliance, and functionality. The full process includes safe isolation, continuity testing, insulation, resistance testing, earth fault loop impedance testing, RCD testing if applicable, recording results, troubleshooting any detected faults. By following these steps carefully, electrical apprentices and trainees can build confidence and competence in ring circuit testing. Whether you are preparing for exams or performing professional installations, mastering these procedures is essential for a safe and efficient electrical practice. Conclusion: ring circuit testing is a cornerstone of domestic electrical work. By understanding the circuit layout, following safety protocols, performing step-by-step tests, and documenting results, you can ensure that every circuit you work on is safe, reliable, and compliant with regulations. Remember, always practice safe isolation, double-check readings, and never skip steps. Over time, these procedures will become second nature, helping you grow into a skilled and responsible electrician.